Welcome back. I'd like to take some time to discuss the function and the operation of what fuses are for. Right. We didn't really do a whole lot of activities in class with the fuses, mainly because it's hard to find obtainable fuses that would work with our circuits, and we had a lot of the things we were doing with the simulator, so we didn't do a lot with fuses. So to understand fuses, I built a basic series circuit where it has an 8-volt battery. Right. I have 2 light bulbs. I have a fan. Right, you can see that we have our stuff functioning fairly properly. The fan is turning a little bit inconsistent, but seems to be working fine. So we have a pretty steady flow. Well, there's times in life where you'll have a power surge of some sort, or you may have an abundance of electricity that you don't necessarily want for various reasons. Could be in a car, could be in a house. Right, and we have 2 things that we use a lot of times to prevent objects such as the fan or such as your light bulbs from bursting. Because a lot of times those can be expensive. Fans in the upward price of hundreds of dollars, okay, or maybe a piece of machinery. Maybe you have a drill press. Maybe you have a power saw. Maybe you have a 60-inch flat screen TV. You don't want one of these abundance of power ruining and damaging some of the electronic parts of these devices. All right. Another fancy word for that would be the load. So our bulb, our fan, our TV, our table saw, our Xbox, all these various electronics that we have in there. So a lot of times what they have is they have a fuse. So I'm going to turn this off. Okay, I'm going to hook my wires up a little bit differently. So I'm going to add a fuse in here. And what we do with a fuse, right, fuses are usually rated for amps. All right, so right now we have a 1.5 amp fuse. Well, I turn this on, very, very quickly this fuse burned out. Right, you can see it turned black and everything shut off. So I'm going to take that fuse. I'll leave it up here just so you can see what it looks like when it's blackened. I'm going to grab a new one. I'm going to turn the power off. I'm going to put our new fuse in there. I'm going to change this up to 3 amps. 3 amps. We turn it on. Okay, and things are running smoothly. Okay, things are operating how they should. The fuse has a little strip of metal running from this metal tab and this metal tab, right? These metal ends, which we know that metal is a conductor. So this metal conducts it. The glass in the middle does not. So you can grab the fuse in the middle. You don't have to worry about any sort of shock. Nothing's going to hurt you. Now, it could break because a lot of times they are glass. Some are plastic. But these metal ends are obviously conductors. So they complete the circuit, just as though that piece of wire would do. Running inside of the glass area is another piece of metal. And this piece of metal, this little metal strip, is rated to a certain amount of amps, a certain amperage. We measured some of the amps with our D-cell batteries in the lab, and we were measuring possibly up in like the 6 amp range. So we have 3 amps running through here. Everything's working well. Well, let's just say that we have an increase in voltage. So I'm going to say 10 volts. Rather than this fan burning out, the fuse burns out. You can see that this fuse burns out and everything turns off. So the power will turn off, or your lights won't work in your car. We take that fuse. I'm going to add it with a piece of wire. Notice what happens if it was without a fuse. The light bulb turns out. Well, to be honest with you, a fuse oftentimes is way, way cheaper than replacing this whole device. So rather than having to go change the light bulb and go get a new light bulb and go buy it and put it in, a lot of times they'll be able to just change the fuse. Again, this bulb burns out. So I go grab our light bulb. I add it in there. Okay, this bulb burns out. So you can see that you would keep burning these objects out, or what you can do is add a fuse. Now right now with the amount of volts that we have, okay, and our amperage being what it is, okay, I'm going to go change 1.5 to 3. But we already know that we changed the other one to 3 and it's still burned out. So what I'm going to do is I'm going to change our internal resistance to 5 on our fuse. 5 ohms. We turn it on. No longer have a problem. We can increase this voltage again, maybe to 12. 12 volts, we're speeding it up. But this fuse is the separator. It's kind of like a wall. It's like a defense wall in between the object and the power source. And this fuse will blow, just like they did right here, or they blackened. If I go put an old one in there, that piece of metal is broken inside and no longer conducts the electricity, so the fuse does not work. If I go put a new fuse in there, does have a good piece of metal, it conducts the electricity. So that's the function of a fuse. We also have circuit breakers. There are no circuit breakers on our DC board here, but circuit breakers have the same function, but instead of blowing the fuse where you have to go change it and put a whole new one in, the circuit breaker flips open, it breaks the circuit, thus the circuit breaker. Okay, it's breaking the circuit. So if this were a circuit breaker, it would flip open. We no longer have a circuit. You go down, you flip the circuit breaker, or your parents might go flip the circuit breaker back over to the on position, and it continues working. But usually if the circuit breaker is going, it means that you have too many things drawing power in your house. You have too many fans plugged in, or a blow dryer, or too many lights on, or your TV's on. You have all these different electronic devices all drawing power from your power source. Well, it's not the blow dryer and the TV you're protecting, it's the wires. Because if you run too much power through the wires, and we keep adding devices to all of this supply, we're trying to get too many volts, too many amps flowing through that one piece of wire, and what can happen is that wire can catch fire and your house can burn down. So these circuit breakers and these fuses in your home protect the wires and the devices. If you get a power surge, it'll protect the devices. But the circuit breaker in your house also protects your wires from having too much current flowing through them and starting on fire. And that's the purpose of circuit breakers and fuses.